to trickle in. Thanks for joining us. We're going to get started here in a minute, just waiting for some. We thought of it because of all the hackathons that we were doing, and a lot of people had questions about this topic. Started here in a minute, just waiting to learn about it and do some of the things that Gustavo's going to go over today. So that's how we, how this came about. So we're excited that you guys are here. Okay, I'm going to get started. So yeah, thanks again, everybody. We're excited that you're tuned in today. Today, we're going to learn how to build an AI multi-agent system capable of autonomously orchestrating decision-making between specialized agents and their tools with Gustavo, who is our staff technical services engineer. So I'm your host, Bobby Lee, leading all community operations here for CDP. So today we're going to run through pulling data from a Hugging Face datasets repository. Then we're going to be creating a pipecone vector data store. Then creating an agent graph with shared state. Then creating agents with their specific tools. And lastly, putting it all together into an autonomous multi-agent workflow. So just a couple things before we get started. We will have a Q&A session towards the end of the presentation. So throughout the discussion, feel free to ask questions in the chat. No need to raise your hand. We won't have anyone speak on stage beyond me and Gustavo. So just post those in the chat. We'll be monitoring them and we will answer them in the end, most likely. And then keep the questions, please keep them relevant to the topic and be respectful to everybody who's speaking and presenting. And lastly, this discussion and session will be recorded and available later for viewing on our Coinbase YouTube channel. And we will post that in the YouTube channel here in Discord. So look out for that when it's ready. And we're going to get started now. So without further ado, let's get started and hand it over to Gustavo.
Cool. Thank you so much, Bobby Lee. Great. I'm going to share my screen, but before that, well, as I do that, give me 1 second. All right. I'm getting captioned, of course. Bridge. All right. We can all see the Google Colab notebook. Can I get a yes, Bobby Lee?
Colab research, yep.
All right, cool. Yeah, so before we get started, I just wanted to say, what my hopes are for this and what this hopes to show. So this is really going to show us a basic of how to create a foundational multi-agent graph. And in that sense, you'll see that we can create the foundation of the topography of this graph. We're going to create some tools as well. So the agents will have their own tools that they can make use of. We're going to share a state between them so these agents can talk to one another. And we're going to have it work autonomously. So my hope is, again, I've shared that link for that repo on our chat right there. My hope is that with sharing that, with going over what the notebook is cell by cell, that you'll be able to gain an understanding of how a multi-agent graph works. And with the repo and with this video, then you can go ahead and make your own kind of flavor of this. So you can create your own agents with their own tools. You can create your own graph topology. And you can create your own, you can add your LLM model. For example, we're going to be using GPT-4, but maybe you want to use something else that you feel is better suited for whatever it is that you're cooking up. Or maybe you want to, give each of your agents different LLM models because, as we know, some LLM models do better with certain tasks than others. And so that's what my hope is, really. This is going to be kind of a simple graph here with a couple of agents working together, sharing context. Also, before we get started, I wanted to talk about costs. So as I mentioned, I'm going to be using OpenAI's GPT-4 model and their text embedding model. And that means that we're going to be using their API keys. We'll get to that in a second. That's also listed on the repo, how you can go ahead and get that if you don't have that already. So make sure that you're aware that making calls to the LLM model and the embedding model is going to generate some costs. It's not going to be high, but depending on the amount of data that we want to sift through, those costs obviously will go up depending on that data. And I'll kind of allude to that where you should be mindful of that during our presentation. So keep in mind those costs. Also, we're going to be creating a vector database that is free. There's a free tier for Pinecone. Obviously, we're using Pinecone. You can use Weaviate, Chroma. There's other solutions there as well. There's a free. I'm using the free plan, but if it gets too large, also there's going to be some costs included in that. So be mindful of that. And lastly, I just want to make sure that you understand if, for example, we're going to be giving this model our API keys or access to our private accounts where we may have a payment set up with these providers. So if it's something else you want to create, for example, you want to trade or you want to do some research and trade, be mindful that depending on the API keys and the abilities that you give to your agent, they will be able to make autonomous decisions depending on what instructions you've given them. And so that's a little bit of housekeeping there. Please make sure that you're aware of all these things because I would not want for somebody to create something and it go off and create a bunch of charges or something like that. All right. So if you have clicked on the repo link there that I shared on the chat, you'll be able to see that there are two files. One of them is what I'm looking at. You can actually, there's a button there that says Colab, run on Colab. Click on that button. It'll take you to this notebook. Basically, this is a web hosted service by Google. It's a Jupyter notebook. If you don't know what a Jupyter notebook is, it is something that a lot of people in data and ML work a lot with. Basically, it's mostly used for Python. And so we'll be able to see it. It's great for our purposes because we'll be able to run cell by cell and see those outputs and see the progress as we go. There's also another file that I've included there, which is basically an archive scraper. Archive is it's a website where I think one of the most important websites where research papers are submitted to and available for free in their PDF versions with abstracts. And so I created a scraper there that if you want to scrape your own papers, because there's a bunch of categories you can scrape, and you'll see why as we're going to use some of that. So again, the first step that we need to take is download our Python dependencies here. And this is going to allow us to make use of the different things that we need for this project. And so, for example, we have datasets from Hugging Face. We have LangChain for Pinecone. It's a built-in library that allows us to talk to our vector database. LangChain for OpenAI, so we can talk to our model. LangChain Core, Semantic Router, which is going to help us embed our text. SERP AI, which is going to allow us to make search Google essentially as an API, and that'll be it. Second part is, and this is optional, I did want to include a RAG or retrieval augmented generation here, which is basically your LLM will be able to talk to a database full of documents that have been essentially created a vector form so that you can get similarities and receive those results. If that's a handful, if you're not sure what that is, basically, you can think of why is this useful rather than searching the internet. For example, you may have, if you have a company or private documents that aren't exposed to the internet, if there are some documents, for example, an archive, which, you have the abstract on the web, but most of it resides on a PDF, 50, 60 page paper. What this will allow you to do is grab those the text of those PDFs or documents, whether it's private or whether it lives in PDF and it's not accessible via net, and you can create vector embeddings, which is essentially going to turn them into a large array of numbers, which can be used to create, which we can query and find out how similar the results of those documents are to what we are asking our LLM to do. So it gives us further context. And what we're going to do, I thought it was very helpful. A lot of LLMs work with a RAG tool of sorts. So I wanted to include that in this particular example. And so what we need to do is essentially here is get data. I created this. Basically, what I did was scraped archive for blockchain papers. I chunked it semantically. So without going too much into it, there's different versions of how you can chop up long documents so that you can then query. You can't just store one huge 60-page document and then query it, because that's not very well. First, there's size limitations, but that's not very useful. And semantic, before we just used to like cut them off at random sizes, for example. So you would set a limit of tokens, for example, and then we chop it. There's a new way of doing that, which is semantically chopping them up. And so that's going to mean that if sentences go together, depending on how much that sentence has to do with the next one or not the next one, it'll chop them up. And that way we can get the pieces. We will chop them up by pieces where the meaning makes most sense. And so those chunks aren't just going to be cut off at a random token rate. They're going to be chopped up when the meaning of the next sentence doesn't really have to do with that. So that's a great way that you can have your data set up. And so I've created this particular data set here on Hugging Face. I have some information about Hugging Face on the repo there. Hugging Face also hosts open source ML models, and they also have data sets. So you can see my data set here. I also have the non-semantic chunk version if you want to see it. If not, you can use this one as well, or you can use, again, the hope is that you can come in here with this code. You can then choose to load whatever data set it may be. There have thousands and thousands of data sets that you may want to work with instead of this. And so you can do that. So we've loaded that data set. Now let's check out, what the first piece is and what the second is. Let's see. And so we can see it's basically, we can see the features here. We have the ID, the title. The title is the title of the article, the archive article. This is the chunk that's included here. And then I've just pre-chunked. I've just included pre-chunk and post-chunk. So that when I'm making calls to my LLM, it kind of knows essentially where it's getting it from or what's related to it in the context of the larger paper. And the reference is basically the archive ID. All archive papers have an ID, and this will help us in a bit, as you will see. And now we need to initialize our embedding encoder. Essentially, when you talk to an LLM, LLMs don't understand words, they understand numbers. And so we have to encode our words into a number so that it'll be able to, create meaningful responses. So it's asking me for my OpenAI key. Again, I've included a link here where you can get that OpenAI key if you don't have one. And again, this is another part where you can choose to use another encoder. For example, Hugging Face has a lot of open source encoders there as well. You can use that. I'm choosing to use this one because I'm familiar with it. I've used it a lot. Next is our Pinecone index. This is going to be our database where we're going to store all of our vector embeddings of the data that we just downloaded from archive, the semantically chunked data that we just downloaded. And again, just initializing. I'm going to give it my API key here as well. You can go to that website there, create an account, and get your own API key. Very simple, and this is going to be free depending on the size, but I've gone up to pretty large sizes. While it's free, they started with one index for free, so one instance of a data store. Now I think you can go up to like 3 or 5, so that's pretty cool. And this code right here says, I want my index to be called this name. If it isn't in there, create it. If it's not, if it is in there, tell me what it is. And I've actually gone ahead and pre-populated this vector database because it does kind of take a while, which is this second part here. So if you don't have it, I've included the code so you can upload your the vector databases the vectors that you want into your vector database. And one thing that I'll say here very quickly, if you're not familiar, some things to keep an eye on. The dimension will have to match the dimension of your encoder. So OpenAI's text embedding 3 small, it encodes it into 1,536 dimensions. That's just, think of an array with 536. And so each spot of that array is considered a dimension. And that's how similarity is calculated within vector. I mean, if you're good at, if you know about linear algebra, this will make sense. And the other thing that I talk about here, that I consider here, is the metric that you want to pass on into your vector database. So that is going to be the metric that your vector database will take into consideration when it wants to calculate the similarity score. I choose dot product because I think it's the fastest one. But for example, OpenAI does tell you sometimes, to go for cosine. That's a little bit slower, but you can do your own research. There's also Euclidean, but do your own research there about what you want to do or what metric you want to include here. But if you want to leave dot product, that's fine. But again, just make sure that the dimension, if you're using another embedding model, that it matches that, and you'll find that in the documentation. How many dimensions this embedding model is embedding into. Again, I've gone ahead and pre-populated my vector database. And so I'm not going to do this. This essentially, if I ran it, it would start loading all those vectors that I'm embedding here. So it'll go through embed with the embedding that we escalated, and then upsert, and it'll be doing it in batches of 128 minutes. For I think I'm doing about 18,000 here. It took about 7-8 minutes, and so I didn't want to put you folks through that. So if you're following along, apologies. It may take a little bit longer to populate your vector database, but if you do have one that's already populated and you're following along, then that'll be good. So now we're going to get to finally, to defining our graph state. And again, we're going to be using LangChain Core here for doing that. We're going to, as you can see, what is the agent state going to be like? We're going to have an input. So somebody's going to ask a question, a query. We're going to have a chat history. That's going to be a list of those base messages, which is, we're getting that from the LangChain Core. And then we're going to have intermediate steps, because we're also going to be able to see what steps our agent is taking and what agents it's telling to do what things when we actually run this. So that's going to be cool. You see a little bit more here that I've described here. I've included a lot of text here, descriptions, if you want to, check it out afterwards. But for the purpose of time, I'm just going to keep going here. And so now we're going to include some custom tools, right? So that's the meat of the agent is it should have, your multi-agent should have agents, and those agents should be able to make use of tools. And so the first thing that we want to do is a very, very simple tool here. It's going to be a tool that can fetch archive articles. Again, archive is where a lot of research papers are published. I chose that because a lot of cryptography, blockchain papers come up, almost daily, certainly daily. And if you want to, have a research agent, you probably want to be up to date. So this essentially what all it does is it makes a call to the archive URL, passes on the ID, use a little bit of regex right here to abstract the pattern, because all of the articles have an abstraction, the abstract, so kind of like a summary of what it is, because again, the meat of that paper is stored as a PDF, and that's why we went through the process of actually creating that vector database, so we can actually read what's inside. I included this number. This is hard coded. I know this is the number. I don't know off the top of my mind. I just checked it out. But yeah, I just wanted to test it out. Again, here is the abstract of this particular article. And so, we can see it's working well. So here is a web search tool. Again, we're going to be using SERP AI. You can use any web search tool that you prefer. I think this is good. It works well. And I'm going to include my SERP AI API key. So just those 3 API keys. This is free, by the way. Again, there's a bit of throttling, but for our purposes, we're not going to be doing a ton of, we're not going to be hitting this too much. And again, this is basically going to query the internet through Google. It is going to give us the organic results, obviously. We don't want to look any paid things. And we're just doing a little bit of adding here, cleaning up the results so we can understand what the context is. And so here I'm passing the query Ethereum just to test it out. And we can see what we're getting here. So we've got seems like the Reddit mod, Reddit forum rather, and the Ethereum org. So yeah, these are going to be your top 2 results here. All right, so the next one, now we're getting into like the more, I guess, complicated tools, but still not complicated, I think. So it's a RAG tool. And again, we're going to be able to do 2 things here with our vector database. We are going to be able to search the entire database for similarity. And we're also going to be able to search filter, so within specific paper, so that we understand with that archive ID that we're getting from our archive fetching, we're also going to be able to filter any results there, so we can actually comb through the entire paper and find those, or give our agent the ability to comb through and find those that information that we want while it's doing its research. Lastly, this, it's a tool. Maybe it's not a tool. It's just a final answer tool. And it's just going to give you a natural language response. It's going to clean up all those steps that it took. It's going to give you more information. So yeah, it could be a tool. It could be a formatter. You can think about it either way. So how do we start? We're actually finally getting into the pieces here of our agent. What we've been doing essentially is creating the tools that we're going to give our agents, and now we have to hook it all up together. And so again, within multi-agents or an agent work, you can create your own topography. So in our sense, and I've included a bit of an image here so you can see what our topography is going to look like, but you can create any topography that you want. It's essentially a graph. And as you understand, if you understand a graph, you can make it have, a parent node can have as many child nodes, and those can have their own child nodes. And so it depends on how big, how crazy, how big you want to go. It really depends on you and your use case. But for our purpose, we're going to make it so that every time I ask a query, it's going to go directly to one point, the enter point. It's going to be the oracle. And this is also a good point for you to actually look at this and say, okay, what do I want my agent to do? This is going to be very important. Again, we are working with an LLM. Why is it disconnected? Let's see. That's fine. So we're going to be working with an LLM. So these are the system prompts. And the system prompts is going to help you a lot. And I've included also a link to OpenAI's prompt engineering in their documentation, which I think does a really good job. So you can understand why prompting these things in the right way is so important. And so right now, as you can see, my prompt just give a user's query and decide what to do with the list of tools provided you. We're providing a scratch pad. That is just some ephemeral state that the agent can make use of when working throughout all the steps and talking to the agents. That is the shared kind of state that we talked about. And that's great because they're going to be able to talk to each other and know what the other agents have been doing, again, so they don't replicate. Again, you'll see don't use any tool more than twice. And unless it's final answer, keep going. All these good things. And we're going to include that in the chat prompt template that also comes from LangChain 4. Okay, so putting it all together here. Now we're seeing, again, we're instantiating Chat OpenAI from LangChain OpenAI. Again, here is where you can choose your own model if you want to. There's tons of different models, open source, closed source. And here for temperature, also, I think, I also want to mention it here. It's good to understand that LLMs are, by definition, probabilistic. They're not deterministic. So if this is something new, if you've been, in engineering for a while, you're probably more used to the deterministic nature of what programming is like. And so temperature is going to let the model know essentially um, what how much free range it can take. Essentially, when the LLM model is deciding what answer to give you, it looks at the probability of the next thing that it should tell you. And it's always, if it's 0, the temperature is always going to pick the highest probability, right? So it's always going to give you the most deterministic output possible. But if you increase that temperature, it's from 0 to 1, by the way. If you increase that temperature, it's going to sometimes pick things that aren't as high on the list. And that's just going to change a bit of how that's going to work with you. So again, depending on what you want to use, or what what the use case is of your agent, keep that in mind there as well. We're passing in the tools that we created. We're giving the scratch pad again, which is like the shared state. So each tool is going to join the research steps again. And we're going to be able to see all those intermediate steps it takes when we run it. And we're binding the tools, we're giving it the prompt, and that's going to be our oracle. So now the nodes of the graph, right? So here we're going to be passing it, for example, the router, which is going to be able to, it's going to be able to route, the oracle is going to be able to route, depending on what it sees it has access to, the agents and the tools that it has access to, it's going to be able to route depending on the problem or instruction that it's been given. And so this is what we're doing here, is we're giving it the ability to route between different things. And yeah, so you can see basically, the intermediate steps, the tool names, all that good stuff here. And it should keep working unless it's the final answer. And if it's the final answer, that's going to prompt it to finish the autonomous loop here. Here's a quick, it's a quick dictionary, just because we are going to do this. Yeah, so it's just gonna, it's kind of help our dictionary. Depending on the tool name, it'll get the tool here. So this is something that's gonna help it, pick the tool that it needs to. It's a function, it's a helper function to get it to pick what tool it needs to, depending on what the oracle is telling you to do. And so finally here, we're putting it all together. We're as you can see, we're actually creating the graph. We're doing the graph state, and we're adding each of the nodes here. So we see the oracle, we see the RAG search filter, the search, archive ID, web search, and the final answer. And so we are also, very important here, setting the enter point to the oracle. That means that it can't just go to any of these nodes. It has to go through the oracle first. And so we have the conditional edges. And so it's going to be, the oracle is going to be the source. And the conditional edges means that the oracle can conditionally go to any of these nodes, depending on what it feels it can do. Because you can also be, again, with a graph, it could be unidirectional, bidirectional. You can create any topography that you want to. If you wanted to always go through a RAG search filter, from the oracle to RAG search filter, and then pick tools, you can do that as well. You can do whatever topography that you want to. And this is, I think, why we're so excited to show this, because we would love for anybody that actually takes a stab at creating their own graph here, their own multi-agent tool. We'd love to see what you come up with, because I'm sure it's going to be some crazy stuff. And so pretty quickly here, again, we have a little display here. Imagine this is essentially what our graph that we've built looks like. So you can see we're starting at the oracle. You can see that these are conditional. These dotted lines are conditional, but it always has to go back. This straight line means it's not conditional. So oracle can choose to go to rack search. Okay, great. But it's going to have to return it to the Oracle. The Oracle is then going to grab that information and say, do I still need more information? And it's going to say, yes. Okay, what tool can I make use of now? Do I need to go to the web? Okay, let's go to the web. This is conditional, but it's going to have to return that to the Oracle again. The Oracle is going to be the one who's going to decide whether or not it has enough information to actually send it to the final answer, and then end and output the result, right? And so here, I should have cleared all these. So here, I have a couple of questions. I think this is a good one. What are the latest improvements in ZK snarks and CK starks? And now if we can run it, we can see it kind of, going through the intermediate steps. It's invoking. We can see RAG search here. Right. We can see web search. It's invoking here as well. And we can see that it's, working through the different tools and different actions, and it's actually found a final answer. This is a helper function here just to build a report, just so it's easier for us to see what it's like. And let's run it and see what it's like. So we have the introduction. Zero ZK proofs crucial component in enhancing privacy and scalability of blockchain technologies. That looks great. All right, but what we want to see is the recent advancements, right? Well, we can find that out on Wikipedia, but let's see what it actually found through those papers and web search. Significant leap forward, offering more efficient, scalable solutions compared to previous systems. Lattice-based snarks, which I'm not sure what that is, but I would love to read more about it. Utilizing noise flooding technique to achieve smaller proofs of lengths, which is crucial for practical. That sounds like a pretty cool. And so, you have your conclusion here, and then, pretty cool, you have the sources. So you have all these sources here that you can actually go to and take a look at. I have some other questions. I think, yeah, let's try this one just so that we can go ahead and give it another whirl here. And again, here, this is where you can, actually make use of your agent and look at all those steps that it's doing. So again, it's starting to RAG search. It found an archive ID. It's searching the web now. It's filtering through the RAG now with it's looking at a couple of archive papers, right? It's actually fetching the entire archive paper from the web. It's actually searching again, which is cool. So it can make so it can't use the tool twice consecutively. Again, that's just a design decision that you can make that I made, but it can do it as many times as it feels like. So this is, it did a fair bit more work than the first one. So let's see what it came up with. So layer 2 solutions of blockchain technology have gained significant attention. Recent research developments have introduced several two solutions. Okay. So what has it done? Improving transaction speed, reducing costs. Those are always good. Arbitrum and Optimism, nice. Optimism, our fellow friends, base is built on. Yeah. So, again, we have this. We have, the archive paper that it's actually, talking about. Alchemy's DApp store, list of 19 papers, Qcoin. And so, yeah, again, very simple. As you can see, my hope is that with this, with a code that again is in the repo that I shared, and we can share it later if you haven't seen the chat. My hope is again that there are so many knobs and different things that you can actually choose to create your own. Again, topology here. You can have, for example, two oracles with their own tools talking to another oracle. And so, it can get as complicated or as creative, really, as you want to. And again, my hope is that you can, tweak, dial, turn all those numbers there so that you'll be able to create something. If you do, I think the only thing I would ask is please share it with us in Discord. I really would be very excited to see what's going on here. Again, if you wanted to include something like our services for CDP, or CDP SDK for trading, again, I would just, as I mentioned in the beginning, be very mindful that if you do give it access to your API keys or any other API keys, as you can see, it can run here and it does so depending on the decisions or the instructions that you've given it. And so be very mindful of that so that something doesn't happen. So test, test, test. And if you do work with our systems, use a sandbox. But yeah, there are a couple of other clarifications that I could definitely make, but I don't know if we have time for any questions.
Yeah, we have time right now. You can stop sharing your screen if you want. And then
Oh, cool.
I don't know if there's any from the audience right now. So you guys just think of any questions. I have a couple for Gustavo that I'm going to start with, and then we'll just answer more if you guys add some in the chat. So first question I have for you is, what costs or charges should I be aware of for this?
Yeah, as I decided to mention in the beginning, again, in this particular notebook or this exercise, calls to the LLM. That's going to be, I think, in general of any agent that you create. Also the embedding model. You're going to have to embed calls if you want to make use of a vector database, for example. And again, any time that you need to give it, programmatic access, API keys, you should be aware that, if the agent if the agent decides to make use of the tool, it can make use of the tool just as you would. So make sure that, it doesn't have, it can't go crazy or set a limit on the budget or test it out.
Cool. Okay. Thanks for clarifying that.
Mhm.
Okay. Another question I have, what's the limit to the number of agents/tools a system can have?
So in theory, there is no limit. Um, Obviously, in practice, computationally, we're speaking about, a different a different subject altogether. Where are you running this? How fast do you think you want to how fast do you want this to run? It's making computation. Um, I've heard of some very complex models doing very complex things. For example, this research agent was kind of based on OpenAI's deep research, which I still don't have access to because I'm not in the right tier. But I built sort of one, but theirs is obviously, as you can imagine, incredibly computationally um, um, large, but honestly, it can be as large and as creative as you want it to be. Again, always within the reason of you have the computational power to accommodate it. That doesn't mean that making something large is necessarily good. So again, I would just um, tell you to check, test, and see what works best.
Oh, okay, cool. Okay, so next question, because I'm still not seeing any in the chat just yet that we haven't answered. So can I create my own vector data store with my data?
Yes, yes, of course. That's you know, I in that repo I created that scraper for archive. Again, you can, for example, if you're a company and you have, I don't know, if you're a law company and you have a lot of private documents, and you want a research agent to be able to scour through all the documents that you have, for example, that aren't publicly available. You can create, vector embeddings of that, storing in a database, and then make sure your agent, has access to that database, that vector database, the way that we had. But yes, of course, you can create a vector database just like you can create any database. And a great tool is where I'm storing my data set, for example. Go look at Hugging Face data sets, tons of data sets, very useful. As with anything, if you're from the data world, you'll know that you know, having the data, it's fantastic, but it usually takes a pretty long time to clean it and wrangle it and make it work the way you want it to. I tried to do my best with mine. But in any case, the data is there. And you can definitely create any vector database with any data that you feel your agent would be beneficial to having access to.
Okay, awesome. Okay, I have two more questions. So how can I deploy this to an endpoint?
So deployment currently, you can do it in a couple of ways. What I would suggest is so a service like Langsmith makes it very easy to deploy agents. So essentially, what you'll have is an endpoint where you're going to pass a a post request, and it's just going to be the query that you saw me writing there. So that's what it's going to take. It'll think for a bit, and then it'll respond depending on how you created your agent. That or what's better known if you have an AWS account, something like SageMaker. You can create a SageMaker endpoint. There, you may have to tweak my code a bit to get it to run properly, just because it's a notebook. But I think it shouldn't be too difficult. So yeah, I would definitely go with SageMaker or Langsmith.
Cool. Okay, so I have one question in the audience so far. So, um, I think Build Lynn maybe is their name. So now
Well
we
then,
enter
yes.
now we enter the era of programmers telling AI to do work, question mark, and creating companies that collect the revenue done by those AI agents, question mark. So hypothetically, one person can take over an entire industry, just thinking hypothetically here.
I'm of, I've heard of this a lot. If you've worked in engineering or software for a while, you know how many issues there are. Like, you know, we work I worked at AWS in the past. I'm working here in Coinbase. We have some elite programmers. Things break all the time. And until we have like self-healing, all-knowing bots, and again, you know, dependencies kind of break down after a while. It would be very difficult for me to see something like this just take off on its own. What I do think, I hear this kind of apocalyptic thinking from a lot of people who say, like, oh, it's going to take over our jobs. What I hear most people who know or work with this technology say is, almost 100% of them is, if you know this technology, you are going to work a lot better. So what this is good, is the old adage, I guess old by now. It's like AI isn't going to take our jobs. Programmers who know AI is going to take our job. I think that's definitely more in tune with what I'm seeing. I just don't think this is just we're gonna flip a switch and this is gonna start working. We're nowhere near that right now.
Yeah. Okay, so I think the one question I haven't asked you is, can I create my own agents with my own tools?
Yeah, yeah. Again, where we going over the demo. Again, this is a foundation. I've laid out the tools. I laid out the topography. Go in there, create your own tools. Essentially, you've seen how I created each of these tools. You can create it with whatever you want it to be. Maybe, you want it to trade, or maybe you want it to create diagrams, or whatever it is possible to do programmatically, you can create that tool and you create that agent to work with that tool. And so I'm very excited to see if somebody, grabs something here from the foundation that I've added to see what you guys come up with, what you guys build. I think that's probably one of the most exciting parts about it.
Yeah. So I'll have Ellie, I want to have Ellie come on stage to talk about the challenge we're going to run after this.
Yep.
Um, yeah, and so while she's kind of preparing some things to say about that, I just want to say thank you again for doing this workshop. It's super awesome. We had a lot of people at the hackathons having questions about this, and yeah, just kind of a lot of questions around that and people wanting to build something like this. So I'm just really excited that we did this workshop. So, so yeah, that kind of brings us to the end of our discussion. We can continue questions going on in a separate channel that we have, the Agent Kit channel. But before we jump out here, I want to have Ellie share about a challenge. We're going to start running challenges after our workshops like this for folks to show us what they learned. So I'll have Ellie share a little bit about that. Yeah. Yeah, and also if you're listening in from Twitter, you can, DM one of the announcements. We'll make another announcement about the challenge on there, so you can reply to that or head into our Discord and join our Discord and post it into the challenge channel as well to get that badge and to get points related to that. So, yeah, that'd be awesome. So thank you everybody again for being here today. We're super excited to have you, and we're looking forward to more workshops coming soon on topics related to agent kits and commerce and on-chain kit, and all of that's coming here soon. And then if you'll be at ETH Denver, a lot of people from our team will be there in Denver. So that starts the 23rd of February. So a lot of us will be heading there then for the hackathon that we'll be hosting. We're not hosting it, we'll be a sponsor for it. So yeah, we're just excited to see what you guys are building with CDP. If you want to join that hackathon, if you're there, yeah, just reach out to us if you have any questions in the meantime. But thanks again for listening, and we'll see you guys soon.
Thank you so much, everyone.